Hello. All right. So I'll walk through chapter 8 right now. Sorry it took me a while because I was double checking one of these just before I went on because all the body measurements I wanted to make sure I wasn't showing you guys the wrong thing. And I had to get food. I have to eat. I am human. I am not a robot as much as some people think I am. All right. So we have to calculate the dose of a drug given at 500 micrograms per kilogram of body weight. How many milligrams should be given to a child weighing 55 pounds? So we're going to just do the long form way, which is 55 pound, 2.2 pounds, 1 kilogram, and then for every 1 kilogram, we give 500 micrograms, which will equal, what? No. Okay. So 55 divided by 2.2 times 500 equals 12,500 micrograms, which we then have to convert to milligrams, which is 12.5 milligrams. All right, the dose for gentamicin is for preterms and full term is 2.5 milligram per kilogram administered every 12 hours. What would be the daily dose for a newborn weighing 5.6 pounds? So we're going to take 5.6 pounds, convert that to kilograms, and then we're going to do 2.5 milligrams per kilogram, and then and that is for every 12 hours, and for every 24 hours, that is a whole day, because it's asking you what is the daily dose. So this would just become a 2, but it's just a way to make sure that you guys know the method behind the madness. 0.6 divided by 2.2 times 2.5 times 2. So 12.72, repeating. Milligrams every 24 hours. Or per day. Yay. I got it right. Okay. A patient weighing 120 pounds was administered 2.1 grams of a drug that is supposed to be dosed at 30 milligrams per kilogram. Was the dose administered correctly, or was it an overdose or an underdose? So let's figure out what his dose was supposed to be. So he's 120 pounds. So 2.2 pounds, 1 kilogram, and then the drug was dosed at 30 milligrams per kilogram. And then let's convert that in here. So 1,000 milligrams for every 1 gram, because they have a gram here, so that we know what we want. So 120 divided by 2.2 times 30 divided by 1,000. 1.63 grams. So 1.63 is less than 2.1. So this dose was an overdose. The adult liquid dose of medication is 0.1 milliliters per kilogram body weight. How many teaspoonfuls will be administered to somebody weighing 220 pounds? So 220 pounds, 2.2 or 1 kilogram, so that would be 100. So for every 1 kilogram, all right, 1.1, so 10% of 100 would be 10 milliliters. So how many milliliters are in a teaspoon? 5. So this would be 2 teaspoons. If I can spell teaspoons, because you would take it, you'd do 10 divided by 5 milliliter per teaspoon, and you find that that equals 2 teaspoons. But yes, it is 2 teaspoons. A physician desires, he desires, a dose of 40 micrograms per kilogram of digoxin for an 8-pound newborn child. How many milliliters of an injection containing 0.25 milligrams of digoxin per milliliter would be given? I actually looked it up. Digoxin is not digitalis. They're two different drugs. One, I think, is eliminated by the kidneys, and one is eliminated by the liver as well. So you can give it to both patients. And I also looked up cyclosporine. I felt like an idiot because I took that part of my brain that used to know that and put it on the side of the road and ran over it. But cyclosporine is an immune suppressant. There is a antifungal that I think sounds similar, but I couldn't find it. But digoxin and digitalis are in the same kind of area, but one is eliminated one way and one is eliminated the other way. So 12. All right. Yes. Okay. So we're going to take the 8 pounds newborn child, 1 kilogram, 2.2 pounds, and then we're going to do the 40 microgram per 1 kilogram. And then we're going to convert it from micrograms to milligrams. So milligrams, and there are 1,000 micrograms in every single milligram. And then for every single one of those, we're going to have 2.5 milligrams for every 1 milliliter. So, and then how you double check, so that's the same unit, that's the same unit, that's the same unit, that's the same unit. So all those units will be eliminated, and we can all get on with our day. So 2.2 times 40 divided by 1,000, and then divided by 0.25. So 0.5818. 0.5818 milliliters of digoxin, which is a heart medication, I believe. But I should probably shush. Phenytoin. Oh, phenytoin, I believe, is an anti-seizure medication. No, phenobarbital. So which one's phenytoin? God damn it, I can't remember any of my... Oh, yeah, it is an anticonvulsant. Okay. Okay, well, I just know that in Pomeranians, they get seizures. There's a lot of dogs that get seizures. So labs get seizures, Pomeranians get seizures, Chihuahuas get seizures, and so you will use phenobarbital and phenytoin. So a 25-pound child or dog, oh, it's about the same weight as a dog. So we're going to convert that to kilograms. Then we're going to figure out how many milligrams are from that. And then they want to know how many milliliters of suspension, so take the milligram dose and convert it to the milliliters. So 25, 2.2 times 4 times 5 divided by 30. So 7.575 milliliters. This really doesn't count, but whatever. So yes, 7.58. So if we rounded that up, it would be a 7.58. So that's right. Nope. Okay. Stay. Okay, here comes a complicated one. So the daily dose for a drug in the literature is 8 milligrams per kilogram of body weight, or 350 milligrams per meter square of body surface area. Calculate the dose on the basis of the patient weighing 150 pounds and measuring 5 feet 8 inches. So we're going to do these a little bit weird. So 150 pounds divided by 2.2 is equal to 68.18 kilograms. And then 5 feet, we want to change that to inches. 60, so 68 inches times 2.54, which is the conversion for centimeters. So 68 inches times 2.54 is equal to 172.72. 172.72 centimeters. Now we can do the first part. So the first part is 8 milligrams per kilogram. So we can do 68.18 kilograms times 8 milligrams per kilogram. All right, 545.45. Okay. So that is based off of just the weight. Sorry, I'm coughing. So how do we find the BSA based off this? The BSA is off of these two formulas. So I don't like this one. I will not be using this one for most of the problems. I really do. This one is the one I've always used, which is just the height times weight over 3,600 and then the square root. So it's much easier to remember than this one. So, but I will have to show this one for one problem, and I'll explain why. So now we're going to do the height and the weight. So 68.18 kilograms times 172.72 centimeters over 3,600. And I'll take the square root of that. Actually, what am I doing? I'm going to clear all that. Where is that? Where is that? I don't normally use this. Oh, there it is. Okay. Oh, I forgot. This is the dumb calculator. Oh, I'm so used to using my other one. All right, so 68.18 times 172.72 divided by 3600, and then take the square root, which is 1.808. Okay, and then 350 milligrams per meter squared times 1.808 meter square is, no, stop, just 633. So why would you do both? Well, let's say hypothetically that we have a drug that comes in 50 milligram increments. We could then do either 550 or 600, but then we would know that we were overdosing at 650 and underdosing at 500. So like that is something that has happened in the past with some medications, that you do both calculations to figure out where you're gonna give your where you're gonna do stuff. So it's useful sometimes. Is it always useful? Not when I want to go to bed, but okay. So this one I have to show both body surface area calculations. So a dose of a drug is 10 milligrams per meter squared per day. What would be the daily dose for a child weighing 30 pounds and measuring 26 inches in height? This is why I have to show both, because the one body surface area works really well for adults. The other one works sometimes for pediatrics, and usually for very small pediatrics because it's a little bit more accurate. However, when you start to get to bigger numbers, it doesn't matter. So I would normally just use the bigger one, and the easier one to remember. However, you'll see that it's not too far off between the two. So we take 26 inches, 2.54, and then we take 30 pounds, and we divide by 2.2 to get that one. So 13.63, and then 26 times 2.54, 66.04 centimeters. And this is kilograms. Remember to label things. This is gonna get hairy. Okay, so we're gonna do the first one where it's height times weight over 3,600, and then you take the square root. So 66.04 times 13.63 over 3,600, and you take the square root. Just a little overzealous with my square root there. Okay, so take that, multiply by 13.63, and divide that by 3,600, and then take the square root, which is 0.5. Sorry. No, there. Which is 0.5. Meters squared. Now on the other equation, we take, it is weight to 0.425 times height to 0.725, and then 71.84. And then that's all divided by 10,000. So that's the other one that we're going to do. So let me put in our height and our weight. Our weight was 13.63. And our height is 66.04. So let me do this. So 13.63 to the 0.425. Actually, I should probably, let me redo this. All right. Times 66.04 to 0.725, and then times 71 0.84. Don't think I memorized this. I have it written down on another piece of paper because I was double checking all these calculations. Don't think I don't know this off the top of my head. I do not know this off the top of my head. And then that's divided by 10,000. So that one is 0.454 meters squared. Now, why did I go through both of these? Well, so you multiply this by 10, and you get, for this one, you get 4.5 milligrams. And for this one, you get 5 milligrams. The answer in the book says it's 4.5. So I wanted to show that with really light, really tiny people, little people, you might need to use the other equation. However, both equations are perfectly fine, usually. For people who weigh over 100 pounds, and even over 50 pounds, usually the other equation's perfectly fine. So it's just that one in this whole entire homework was the only one where the other equation was needed. So if you're doing this for memory, the other one is not easy to remember, but this one is more accurate though. All right, so mitomycin injection is 20 milligrams per meter squared per day. Determine the daily dose for somebody who weighs 144 pounds, measures 68 inches. So 144 pounds divided by 2.2, and then 68 inches times 2.54. So, nope. 65.45. Don't forget your units. Okay. Because now we're going to start getting into more complicated units and stuff, and it's going to start you're going to start going cross-eyed if you don't remember to put on your units. Okay. So now we got to find their BSA, because we have to find it in meters squared. So take 65.45 kilograms, multiply that by 172.72 centimeters over 3,600. The other thing that kind of giggles my insides, tickles me pink a little bit, is that 3,600 is a unit in the Babylonian mathematics. It's very important. So when we're doing this is probably based off older equations and stuff that are over 4,000 years old. So it kind of, whenever I see the number 3600 and it's used in an equation. I go, that's probably based in Babylonian equations. You can actually, in fact, count up to more than 120 on your fingers if you use the Babylonian counting. So, why did I do that again? Sorry. All right, yes. Size 1.77. Why did I write 1.77? Jeez. I have my notes on what answers are so that I don't lose track of what I'm doing. But, so then we do the 20 milligrams times 1.77. So it's milligrams per meter squared. You need to know what your units are. And see, I'm not trying to be the pharmacy student I was. I'm trying to be the pharmacy student I should be. So if you ever look up to me, don't look up to me. Look up to the pharmacy student I'm trying to be. So you need 35.44 milligrams. Found that is right. Okay, now we're at 41, which I believe is the last one of these body surface area calculations. Yay, we're getting to the end. So 73 inches. I should read the question. I haven't even read the... I'm looking at my notes. God. All right, the drug cabazitaxel is used in treating prostate cancer. You'll find that anything that has like a taxel on it is like used in a lot of cancers. So just note to those who actually want to learn stuff. So it has a 25 milligram per meter squared dosing, and they want to calculate the dose for a patient measuring 73 inches in height and weighing 190 pounds. So gotta find this in centimeters and remember to label stuff, because then later you'll know what you're looking at instead of me who didn't label anything in their notes. So 73 times 2.54. 185. 85. 42 centimeters. I think that's like 6 foot 1 inch. Yeah. Yeah, because 72 inches is 6 feet. 60 is 5 feet. Yep. All right, and then 190 divided by 2.2. So that is 86 kilograms. Well, actually, I should probably put the 0.36. All right, and then, so 185.42 centimeters times 86.36 kilograms over 3,600. Take the whole square root of that and do the whole thing. So 185.42 times 86.36 divided by 3,600. And then take the square root, and it's 2.109. 2.109 meters squared. And so 2.109 meters squared times 25 milligrams per meter squared is equal to probably around 50. So 2.109 times 25, 10.54. What? What? Oh, that's not right. Ah. All right, 2.109 times 25, not 5. All right, 52.725. 52.725 milligrams. Sorry, I didn't mean to give you a heart attack. All right, yep, and that is correct. All right, let me insert some more space on this one. I'm gonna need just a bit more. Okay, there. All right, a high-dose treatment of osteosarcoma includes the use of methotrexate, which I misspelled, because I think it's methotrexate. Yeah. At a starting dose of 12 grams per meter squared as a 4 hours intravenous infusion for a patient having a BSA of 7.2 meters squared and weighing 162 pounds. Calculate the dose on basis of milligram per kilogram per minute. So we're going to take 1.7 meters squared times 12 grams meters squared. Figure out the dose. Ooh, there's two calculators. No, I don't want two calculators. Okay. So 1.7 times 12, 20.4 grams, which they're asking for milligrams. So you multiply that by 1,000. There's your milligrams. And then 162 pounds, divide that by 2.2 pounds per kilogram to find all right, 73.63. 73.63 kilograms. And then we have 4 hours. And then you have 60 minutes in an hour. And so you find that that is 240 minutes. So, milligrams per kilogram per minute. Now we enter this all in the calculator. And we find that is 1.1544. What? What just happened? All right, 1.1544 milligrams per kilogram per minute. Yes, it is methotrexate. I just misspelled it. I was typing stuff up. I was just going too quickly. Okay. So 2-agent dosage regimen, termed MP, for the treatment of multiple myeloma follows Melphan, which is 0.25 milligram per kilogram. It's given days 1 through 4 for a week, for each week for 6 weeks. And then prednisone is 2 milligrams per kilogram by mouth, days 1 through 4 each week for 6 weeks. So calculate the total milligrams for Melphan, oh God, I'm probably mispronouncing, and then prednisone. Melphalan. Okay, so we got to figure out the amount they weigh in the international units instead of in imperial units. So if you guys don't know, pounds is the imperial units, if I remember correctly. So 2.2 pound per kilogram. And then that is 75. Ooh, nice number. Ooh, nice round number. I like it. All right. And then I think I might lose weight till I get to 165 just to make it easier on the pharmacist when I start to die. Because this is going to make dosing so much easier. Okay, so not to be dark, but all right, so 75 kilograms. And then for the first one, which is Melphan, this is Melphan. God, I swear to God. I'm not pronouncing anything. So then, all right, they get 0.25 milligrams per kilogram a day, and then that is for 4 days. So oh, that's 75 milligrams. All right, so they get 75 milligrams. Well, that's day per week. So this is for a week. And then for prednisone, it is 75 kilograms times 2 milligrams per kilogram times 4 days as well for each week. So that is 600 milligrams each week for prednisone. And this is for part A. For part B, if melphalan is available in 2 milligram tablets, how many tablets are required to dose this patient for an entire treatment cycle? So we know that this is the amount for a week. So we just take 75 milligrams and then multiply it by 6 to find out the total treatment amount. Which is 450 milligrams total over the whole treatment, and then is divided by 2 milligrams per tab to find out how many tablets. So that's a lot of tablets. 225. So 225 tablets, and that is for part B. And then part C is if the patient prefers prednisone oral solution to tablets, how many milliliters of the solution, 5 milligrams per milliliter, should be dispensed weekly? Okay, we already know the weekly amount, which is 600 milligrams. Then we just need to divide it by 5 milligrams per milliliter to figure out how many milliliters, which is 120 ml, which is part C. Yep, no, that's right. And then I believe this is, oh no, it's not our last question. We're getting close to the end. Sorry, I'm going to cough. Sorry. Oh. So, vincristine. All right. Oh, okay. All right. 3-dose regimen, termed VAD, for the treatment of mild melanoma includes the drugs taken over a 28 cycle. Vincristine, which is 0.4 milligrams per day. I think it's central intravenous infusion is CIVI. So you have, yeah. And then 1 through 4, days 1 through 4, then doxorubicin. So doxorubicin, Novatrone is blue, doxorubicin is red. I'm so sorry, cancer happened to you. Yeah. So that is the poem that they made us remember so that we could remember that Novatron is blue and doxorubicin is red. So if you ever learned anything about cancer drugs, doxorubicin is red and Novatron is blue. I'm so sorry cancer happened to you. Dexamethasone is 40 milligrams a day by mouth, days 1 through 4, then 9 through 12, then 17 through 20. And this is a 28-day cycle. So calculate the total quantity of each drug over the course of treatment cycle for a patient with a BSA of 165 meters squared. So the only one where the meter squared is needed is that one. So the other ones are perfectly fine. So Christine is 0.4 milligrams times 4 equals 1.6 milligrams for the treatment cycle. And then dox is 9 milligrams per meter squared times 1.65 meters squared, and then that's times 4. So 9 times 1.65 times 4, that's 59.4 milligrams of dox. And dexamethasone, that one is 40 milligrams a day. And so that has days 4, and then it has another 4, and then it has another 4. So that's 12. So 40 times 12, 480. Yep. So there you go. That is how you find that one. Very, very simple. Yep. Getting close to the end, my friends. Now this one, I worked head on. We don't need to know a 4-agent dose regimen, termed MOP, for the treatment of Hodgkin's lymphoma includes drugs taken over a 28-day cycle. Skipping to the end, not going to read off the drugs. Calculate the total number of 20 milligram tablets for prednisone and 50 milligrams of procarbazine, I don't know, to dispense to treat a patient with BSA. Okay, so that means we don't need to know these two. Forget them. They don't exist. So we figure out how much they take. So for procarbazine, bezine. All right, so that one is 100 milligrams per meter square, which you want to have 1.5 meters squared, and then is 14 days of treatment. And then that is divided by 50 milligram tabs. So So 100 times 1.5 times 14 divided by 50 equals 42 tabs. And then the prednisone, that one is 40 milligrams per meter squared. That is also times 1.5 meters squared. And then that is also 14 days. But that one is 20 milligram tablets. And be careful that you don't get these mixed up because in the list, it has procarbazine first, and then later in the question, it has a second, which that's what happened with me when I was doing this in the practice. 40 times 1.5 times 14 divided by 20. What? Oh, I'm missing. Okay, sorry. And that is also 42 tabs. But yeah, so one of the things that you could also look at this is that I noticed afterwards that the 50 milligrams goes into the 100 and the 20 goes into the 40 twice. So very easy to figure this one out, which one goes to what. Okay, so this is the last question. Let me add some more space here. Okay, chemotherapy regimen CAF during a 21-day cycle is cyclophosphamide, doxorubicin, doxorubicin is red, and 5-fluorouracil, which is used in a lot of stuff. Calculate the dose of each drug cycle for a patient with a BSA of 1.9. So this is going to be easier because 2 of our drugs are at the same dosage, and then this one is 10%. So cyclophos is 500 milligram per meter squared times 1.9 meters squared. And then there's only 1 day of treatment. Why are you being 1.9? All right, so that's 950 milligrams. And then dox is 50 milligrams per meter squared times 1.9 meters squared times 1 day as well. That is only 10% of this. So that goes into that 10 times. So this is 95 milligrams. We don't even need to calculate it. Just look right away. And then 5-fluorouracil is 500 milligrams per meter squared times 1.9 meters squared. However, this is 2 days. So 2 days is 1900 milligrams because you just take this one and you just double it. So there you go. That's it. That's all of them. Got that right. Yep. So everything's right. If you have anything you want me to go over from like class, let me know. I'll see if I know how to do it. Sometimes it just takes some jogging of my memory to figure out how to do it.